Welcome to part 4. Part 4, multiphase system. So we are still in gas liquid in equilibrium for multiple components. In part 4, we will look to how to find bubble point temperature, bubble point pressure, dew point temperature and dew point pressure. Okay, when you talk about bubble point temperature, it means that we have liquid phase and we want to change our liquid phase to gas phase. So that's what bubble point temperature. We need to, if we have liquid phase, we need to change. We have liquid sample, so we want to change it to gas phase. And our liquid contains multiple components, so we need to find the bubble point temperature of that liquid mixture. So bubble point temperature. What is bubble point temperature? Bubble point temperature is the temperature at which the first bubble forms when liquid is heated slowly at given pressure. And this liquid is heated slowly at this given pressure, and this pressure is constant throughout the heating process. Okay, that is what bubble point temperature. Okay, so now to find bubble point temperature in a system that has multiple components, so I'm going to show you how to find bubble point temperature for multi-component system. For example, let's say we have in our liquid we have component A, B and C only. We have 3 components A, B and C. So to find bubble point temperature for this liquid mixture, so remember, bubble point temperature is the temperature at which the first bubble form when liquid is heated slowly at given pressure. So look here. So sort of this is illustration. So we have a liquid mixture, but this one is actually I just improvised from single component previously. So this is a 3-phase diagram of a single component, but I still use this figure for liquid mixture to make you understand where is this bubble point temperature. So let's say we have a liquid mixture. So it is initially in a liquid phase at this T1 temperature. So the pressure is here. So one pressure. Okay, so let's say we just say it's pressure because we were not going to change the pressure. So this liquid is in liquid form. Okay, we want this liquid mixture to change into gas phase, into vapor. Okay, so what we have to do, if we fix the pressure in order to change this liquid to becoming vapor, what we have to do, we have to increase the temperature at constant P. Okay, by doing this, we will increase the temperature until the temperature reach this saturation line between liquid and gas, where the point that falls on the saturation line, that is the bubble point temperature of this liquid mixture. Okay, remember, bubble point is actually from liquid to become gas. Liquid to become gas, so the temperature it becomes gas is the bubble point temperature. Okay, so now remember we have our system now contains our liquid contains A, B and C component. To find the temperature, the bubble point temperature for this liquid system that has A and B and C component, what we have to do, we have to use this equation. Remember P of the system is equal to the partial pressure of all component in that system, right? So P, we use this equation P of the system, because if we need to find bubble point temperature, we already know our P, and our P has to be fixed because then we can get the bubble point temperature. Okay, P we already know is equivalent to partial pressure. This is no longer partial pressure, but we use the one that in liquid form. So we have 3 components. So XA times by the vapor pressure at the TBP. We do not know this, so we have to leave this blank. Plus, we know this composition times with its vapor pressure at unknown boiling bubble point plus XC times with this component C vapor pressure at unknown boiling point. So when we do calculation, this calculation is to find to find bubble point temperature. This is a trial and error calculation. So we have to put we have to guess what is the temperature that when we do this calculation on our right hand side, this calculation total up of this total up of this compound will equal to the pressure of our system. Once we obtain the suitable T, that towards the end this calculation equals to P, then that T is our bubble point bubble point temperature for this liquid mixture. Okay, this is how we find the T boiling point, where we have to use this equation to find T bubble point. It's not boiling point, yeah. From liquid to change to gas, it is called in our mass balance class a bubble point temperature. So to find this bubble point temperature, we have to use this equation. Okay, this is for A, this is for B, and for C. So you have to guess what is your temperature. You have to put inside, and then once you have summation of this equal to your pressure of the system that you know, then that will be your temperature of your bubble point temperature. Your right side must equal to your left hand side. So that temperature that you obtain when you have this one equal to this, that is your bubble point temperature for this liquid mixture. Okay, let's say once you already obtain your bubble point bubble point temperature, and you need to find the composition of the gas phase. You know your liquid phase, but you not know the composition of your gas phase. So what you have to do, you have to find the partial pressure using bubble point. This is bubble point. I keep on saying boiling. It's not boiling. Bubble point temperature, because you already obtain your bubble point temperature. So you find your partial pressure at that temperature of the boiling point. Of your bubble point. So you find for B and for C, and then to find the composition, remember this equation from previous chapter. So to find composition for A at this TBP is YA equals to partial pressure for A divided by P. This is pressure of the system that you already know. Okay, for YB, this is the equation. For YC, this is your equation. Then you can solve for the composition of your gas phase. Right. So, that's it for bubble point temperature calculation. To find bubble point temperature, so you have to do trial and error using this equation. I will show you how to do this later in our tutorial. So now let's move to bubble point pressure. How to calculate bubble point pressure. Sorry, just now because I just noticed that you probably don't see this. So P here on the left hand side, P left hand side must equal to your right hand side. So this is the information. Now let's look how we're going to find bubble point pressure, or denote as PBP. This is pressure bubble point. Okay, bubble point pressure is a pressure at which the first vapor forms when liquid is decompressed at constant temperature. We are talking now, we have a system of liquid and we want to change it into gas phase. Okay, this is from liquid to gas phase. If you need to find bubble point pressure, that means we have liquid sample, we want to change it into gas, that is bubble point pressure. The pressure that where the liquid change phase at constant temperature is known as the bubble point pressure. Okay, so let's look into this three-phase diagram, so easier for us to understand what is a bubble point pressure. So it says that pressure at which first vapor forms when liquid is decompressed at constant temperature. Okay, so decompress, that means we reduce pressure. So initially it was here, our system was here, and then we decompress, we reduce the pressure until it falls into the saturation line between liquid and gas. So that is where the bubble point pressure is. Okay, decompress means decrease pressure, so to find bubble point pressure, we have to decrease pressure at constant T. We have different set of pressure, P1 and become P2, but temperature remain constant throughout the process. So in this case, we still can change liquid into gas phase. Previously, we changed liquid to gas by increasing temperature, but we can also change liquid to gas by decreasing the pressure. So by decreasing the pressure, then this is actually by doing the bubble point pressure. In order to find bubble point pressure, let's say in your exam, you need to find your bubble point pressure in a system that contains multiple component. For our system, let's say we use A, B, C. To find bubble point pressure, we have to use this equation. Okay, but it's not difficult because now, of course, for this system at constant temperature, we already know your T. So you know your X, you know your T. So you do this calculation, you can easily obtain your bubble point pressure. Okay, so you can calculate. It's easier than the previous one where we have to find bubble point temperature, because bubble point pressure, this is just the calculation. This is just the equation. We do not need to use trial and error because we know T. We put into this equation for each of these components, then you get your bubble point pressure. To find composition of the gas phase that we have created, so these are the equation. So once you get this bubble point pressure, then you just use this bubble point pressure here. You know your partial pressure of A, partial pressure of B, pressure of C, and you know your bubble point pressure. Then you obtain the mole fraction of each component or the composition of each component in your gas phase. So that is for bubble point pressure. So we'll go to next part, which is part 5. We will look into dew point temperature and also dew point pressure for multi-component system.